All right, this is Calculus 2. This is the second part of related rates. And yeah, okay, so for this one right here, rectangular swimming pool, 10 meters long, 5 meters wide, has a depth of 3 meters at one end, 1 meter at the other end. If the water is pumped the pool at a rate of 300 liters per minute, what is the water level rising when it is 1.5 meters deep at the end? So I'm going to start by drawing it. So we say something like this. So it's 1 meter there, 3 meters there, 10 meters here, and and it's 5 meters going that way. Yes?
Yeah.
Okay, so that's my rudimentary drawing on this. Okay, so now. Okay, are you like mind blown right there? Are you okay?
It's just a pair of eyeballs.
It gives me like
man.
it gives me like 2 days.
Here, this is the piece that we're focusing on. 10, 1, 3. Okay, that's the piece that we're going to focus on. So the 5 is going to be important, just not yet. Okay? All right, so we have a couple things here. So I'm going to start with this piece right here. So I'm going to have that this piece is going to be my 10, right? This piece, what's this piece down over here? Just the bottom piece. 2, all right? Okay, so that's kind of the stuff that I'm going to need there. And isn't this going to be like a prism, right? So it is a trapezoidal prism. So it's basically a trapezoid with depth. So it's extending that way. So now, we know that we're going to have a related rate here. So the first related rate was the dV dt was how much? It was in the word problem. 300 liters per minute, right? Yes?
Yes.
Okay, good. All right, so 300 liters per minute. Now, as I go back to the question, let's see. Okay, water's pumped into the pool, 300 liters per minute. What rate is the water level rising when it is, so let's first, water level rising when it is 1.5 meters deep. Okay, so rate of the water level rising. So now I'm going to actually mean that it's going to go up this way, right? Yes? So I'm going to call it an H. I'm going to call it an H for this case. So it's going to be dH dt. That's what I'm looking for, right? I'm looking for the rate, and it said when H is 1.5 meters. Okay. So now, if I'm going to the 1.5 meters, because this is the part that you have to like really pay attention on. Am I using the whole trapezoid? No. I'm only using the triangle bottom, right? Because this is 2 meters, right?
Yep.
So if I get to 2 meters, then after that, it's actually changing, isn't it? So all this right here is just a rectangular prism. So if I go above that, then it's going to be changing and dealing with this volume here included, right? So it's the volume of this times plus the volume of that. So as I'm increasing to that, once I actually fill it up to there, it's going to be a different equation here. But I'm only going to deal with the bottom, right? Say yes.
Yeah.
Okay, good. So that's going to help you out a lot. So now I have everything I need set up here. But first, how would I find the volume of that shape? How would I find the volume of the shape? So we'd say the volume is equal to, now remember, we're only dealing with the bottom piece. What is the shape of the bottom piece here? Triangle, okay? Isn't this just going to be a triangle for the volume? It's a triangle with thickness, isn't it? So I would find the area of this times the thickness, like how long is this piece right here? Okay, so if I do that, it's going to be my h is going up, right? So it's h times whatever my length, right? Divided by 2. That's the area of the triangle, right? Now, since we're trying to find the volume of it, it's the area times the depth. So what is the depth of this? How wide is this going to be? 5 meters. Very good. So it's 5 meters. I got that from up here. Like, I needed that information. That's why I threw it in my equation, or this thing up there. All right, so I'm going to have that much information. So since the W is really not going to be part of this that I'm going to be worried about, I'm going to just throw in that 5 there. Because that's actually has nothing to do with it, is it? So that's going to be constant. It's going to stay that. That's not going to affect this at all. So I'm going to get that volume is equal to, let me see, 5 over 2 HL. Yes? So volume is equal to that. So now there's a couple things I could do from there. So now I know there's some things that I need to deal with. Since I have a V, I have an H, and I have an L. Now I need to set this up to try and solve for one of my other variables, either the H or the L. So I'm going to use a similar triangle, because in this, right here, so the water level is only going to go to here, right? So right here, is that going to make another right triangle? That is going to make another right triangle. And these triangles are going to be similar to each other. They're going to be proportional. So whichever this value is going to be proportional to this value up here, right? So by setting this up, I could actually eliminate one of these. Because this, the 10 represents my what? Which one of these variables down here does the 10 represent? The L, right? Okay. So, and the 2 represents the what? The H, right? So I can go 10 over 2 is equal to what over what? L over H. L over H. Because it's similar. So this is my L here, and this is the H. Because I'm going to use proportion to get rid of one of these. Because I have too many variables here. Okay, because I have a value of H, but I don't have anything in terms of L, do I? So I'm going to eliminate the L from my problem. Does that make sense or no? Okay, it's just basically I'm going to isolate my L and replace all my L's with something in terms of H.
Oh, that makes sense.
Yeah, that's all I'm doing, okay? So that's what I'm doing here. So now I'm going to multiply both sides, so I'm going to get what? So this is going to give me 5H, right? 5H is equal to L. So I can now replace the L with 5H, right? Okay, so I'm doing that now. So it's going to be V is equal to 5 over 2 times L, which is 5H times H. So now I have V is equal to 25H squared over 2. Are we okay? By using my similar triangles up here, I was able to get rid of those. And so now from here, I could actually go ahead and do this. So now I have an equation for V. I have an equation for V, so I can go ahead and take my derivative now, right? So since we said that, V is 25h squared over 2. My dV dt is equal to 25h. Am I missing anything there? What is it? dH dt, right? Okay, so now what value am I trying to find again? What am I trying to find from this? dH dt, right? Since I'm trying to find dH dt, I need to work it backwards, don't I? So, I know that I'm going to move this way. But now the dV dt. So it gave us that dV dt is 300 liters per minute. Now, I got to do a unit conversion here. Because I'm looking for everything in terms of the height, right? But if it's in terms of the height, isn't my height supposed to be in meters? Yes. My height is supposed to be in terms of meters. I can't have my height in terms of liters, right? So I have to convert that. So I know that 300 liters over 1. Now, if I do a unit conversion here, what goes on bottom? Liters go on bottom, right? Because I'm canceling out liters. So it's going to be liter there, meters cubed here, right? Okay, for volume. So I'm converting it from liters to volume, right?
Yes.
Did I lose anyone here? Anyone? So speak up if I am. Okay. All right. So now I need to take a look. So now, which one's bigger? Is it a meter cubed or a liter? Here's a meter stick. And here is a liter drink. It's actually a liter and a half, but anyway. So it would be one of these this way, one of these this way, and that way. So that would be the volume cube. So which one's bigger? Meters. So meters cubed. So meters cubed, 1 meter cubed is how many liters? Metric system works really good. I had to look it up.
Okay.
I was like, dang.
That's crazy,
Dude.
man.
It's in meters and meters. How long is even a liter?
Okay, so now I can do my conversion now, right? So I cancel out my liters. Liters go away. And so it's now going to be 300 over 1,000, which is 0.3, right? Or 3/10. Okay, so I get 3/10 meters cubed, right?
Yeah, that's our dV/dt.
Yeah, that's my dV dt now. So I can go 3 over 10 is equal to 25. What is my h value? 1.5. I like fractions. What is 1.5 as a fraction?
3/2.
Okay, 3/2. And we're trying to find dH dt, right? Okay, dH dt. So what am I going to do here to try and get that by itself? Divide both sides, right?
Yes.
Okay, so I'm going to divide both sides. So it's going to be 3 over 10 times 75 over, oh crap, I need to flip it. 2 over 75 is equal to dH dt All right. Okay, because I multiplied it on this side, then I just, to the other side, multiply by the reciprocal. So dividing is multiplying by the reciprocal, right? All right, so now right here, I could do some canceling. So let's cancel that. That's a 5. Cancel that, and that's a 25. So now it's going to be 1 over 125 is equal to dH dt.
Well, the units, but
Okay, so what are the units going to be on this?
meters.
Meters per minute, right? So it's going to be this meters per minute. So if I divide it out, it actually comes out to be 0.008. Is it 0.008?
Yes.
Yeah, okay. 0.008 meters per minute. And that's the rate in which that the pool is being filled at that time.
That's pretty crazy.
I know, it is crazy, right?
Why did they want to know like at that moment? That's weird. That's pretty cool though that you can do that.
Oh, okay.
Okay, wait. It's rising at 0.008.
All right, so let's take a look at the next one then. Person standing at the end of a pier is docking a boat by pulling the rope at a rate of 2 meters per second. So I have my
That's nice drawing, Patrick.
Oh, you think it'd be a classic boat?
all right, so we said that the rate of 2 meters per second and the rope is 3 meters above water level. So this is 3 meters. This is going to be X, and let's call that one L. Okay, it's asking for 5 meters rope are left to pull in. So 5 meters, so that means that, so it's pulling it this way, right? So it's going this way. So it's pulling it that way. So it's asking when L is equal to 5. When L is equal to 5, I'm trying to find the rate that it's going in here. So that's going to be my rate coming in, pulling in a rope at 2 meters per second. So dL dt 2 meters a second. And how fast is the boat approaching the base? Okay, so the boat is going this way. So it's asking for dx dt. All right, so we picked through the problem. We found everything that we need. Okay, and we went around trying to find it all. Okay, so a couple things that we know. I know that when, let's take a look. It says L is 5. That's a right triangle, isn't it? So if L is 5, I have a little triangle right here. Looks like this. This is 3. That's 5. Hey, can I find this piece right here?
Yes.
Yes, you can. Can we do it? Yeah. Okay. Anyway, all right. So you guys, what does it come out to be? 4. Why does it come out to be 4? It's a Pythagorean triple, right? It's a Pythagorean triple. So yes, you can do Pythagorean theorem. You get x is 4. So that's another good value that I have. So x equals 4. All right? Okay, so let me see. So since I'm trying to find the rate of changing here, I know it's going to be 3 squared plus x squared is equal to L squared, right? Yes?
Yeah.
Because I'm trying to find the rate at when x is changing. So to find the rate that x is changing, I need to actually do a derivative with x in it like this, right? So I did Pythagorean theorem because I knew those values at that point, but now I have to figure it out. What's the rate at that? So now take the derivative. What's that 3 squared do? Goes away. So I'm left with 2x dx dt is equal to 2l dl dt. Okay, so I'm trying to find dx dt, right?
Yeah.
Trying to find dx dt. So now I know I could just do this, right? Divide both sides by 2x and I'll get my dx dt, right?
Yeah.
So it's going to be dx dt is equal to 2l dl dt over 2x. Do we have all those variables?
Yes.
Yeah, we do. So it would be dx dt is equal to 2 times L. We said L was
5.
5. dl dt was
2.
2. And 2 times my x, what was my x value? 4. All right, so do some canceling. So bam, bam, bam. So we're going to get dx dt is going to be equal to 5 halves. So it's 5 halves of what?
Meters a second.
Meters.
Per second.
Meters per second. You guys good on this?
Yeah, actually.
I like doing these ones. These ones are like,
They're a couple parts long.
yeah, they are long, but it's kind of like a puzzle. It all fits in together.
Yeah.
So if you list out everything, it makes it easier to actually figure out what you're missing, what you need to find, and what you could get from that. All right. Let's see. Next one. Revolving light located 5 meters from a straight shoreline turns a constant rate of 3 rad per minute. Okay, so let's go to the drawing board right here. So right here. So there is my lighthouse right there. And they said how far off? 5 km. And a angler speed of 3 rad per minute. So I know that's going to be a d theta. dt is 3 rad per minute. With what speed is the spotlight moving along the shore when the beam makes an angle of 6 degrees with the shoreline? So let's see. So we're looking at an x here, and we know it's going this way, right? And so, and this is going to be 60 degrees here when it makes 60 degrees with that short line. Okay. Did I confuse anyone with my drawing, my sketch, my explanation? Because when I'm talking about angles, that's usually a pain in the butt, right?
Yeah.
All right. What can I find? Can I find x?
No. Well, wait.
Say yeah.
Yeah, because we have the.
You have one of the angles, right?
Yeah, we do.
So if I'm only think about it in the terms of a right triangle, that's 60, that's 5, that's x. So if I'm not talking about the rates right now, if I'm not talking about the rates, I know this is how much I have, right? This is at that current second where they're actually talking about it. I'm looking at a triangle that looks like this, right? So I could solve for x, can't I? I could solve for x here. Okay, let's go ahead. So from this angle right here, what am I going to be working with?
Cosine.
Nope, try again.
Tangent.
Tangent. Cosine needs the hypotenuse, doesn't it?
Oh
Yeah.
Oh,
Yeah?
yeah.
I'm only going to be working with tangent. So it's going to be the tangent of 60 degrees is equal to 5 over x. Okay. So let's take a look here. So let's do a little bit of finagling, right? Multiply both sides by x, then divide by tan 60. So I'm going to get x is equal to 5 divided by tangent of 60. Right? Because you start by multiplying both sides by x, then you divide by 60, tan 60, right? Okay, so now, tangent at 60. Let's see, tangent is sine over cosine, right? Sine 60 over cosine 60. Sine 60 is going to be rad 3 over 2. Divided by cosine at 60 is 1/2. Can't divide fractions, got to multiply by the reciprocal. So multiply by the reciprocal, so it's rad 3 over 2 times 2 over 1, which gives me just rad 3. So I know it's going to be 5 over rad 3. So I know x is equal to 5. Wow. Okay, so x is equal to 5 over rad 3. Okay, so that helps me out. So what are we trying to find now? Let's go back to the question. What are we trying to find? Okay, so what speed of the spotlight moving along the shoreline? Okay, so speed of the spotlight, that has to do with x going that way, right? So the speed of that would be, what would I call that? dx dt, right? So that's the piece I'm looking for, dx dt. Okay. All right, so now we're trying to find it from the angle, right? The angle, this angle right here, my theta, right? So I'm working with the x, and I'm also working with the 5 over here, right?
Yeah.
Okay. So at that same time, let's take a look. Because I'm going to need a value for theta.
30.
Why is it going to be 30?
30, 60, 90 triangle.
Yeah, it's a 30, 60, 90, right? You guys see that?
Yeah.
So theta, that's going to be another value that I have over here. So theta is 30 degrees. Okay. So now, again, we're working from this one. So we're working from my lighthouse over here. So opposite and adjacent is what I'm working with. So that's going to be tangent, right? So I'm going to have tangent of theta is equal to x over 5. Okay. Multiply both sides by 5. I get 5 tangent theta is equal to x. Now I'm going to take the derivative, because that's going to give me my rates of x, isn't it? So that's going to be 1. So it's going to be, what's the derivative of tangent? Secant squared. Theta. And what am I missing? D theta is equal to derivative of x is just going to be dx dt. All right, so 5 times secant theta. Okay, so theta is going to be 30, right? Okay, so 30 So let's take a look. Isn't secant just the reciprocal of cosine, right?
Yeah.
So cosine at 30 we're at 3 over 2, isn't it? But secant's the reciprocal, isn't it? So I'm going to just plug it in as is. So it's going to be 5 times the reciprocal, which is 2 over rad 3 squared. That's my secant squared theta, right? Times d theta dt, which is 3. And that's going to be my dx dt. So now, if I go through and square this, let's see, that's going to be 4 over 3. 4 over 3, right?
Yeah.
4 over 3. What's going to happen to that 3 in the top and bottom? Those are going to cancel. That 3 and the 3 on the bottom is going to cancel. So it's 4 times 5, which is 20. So I'm going to get 20. What are my units? No, remember we're finding dx dt. What is the units of my x? Kilometers. So it's km per minute, and that is my dx dt. Are we okay?
Yeah.
Okay. There we go. All right, you guys. Don't forget, like and subscribe.